Okay, just received this 950, suffered a power surge. It was actually diagnosed by Yaesu. Anyway, so we're going to get into this radio and see exactly what it's going to take to get it back on the air. First things first, I hooked the radio up to a very low current 3 amp max power supply and plugged in. I'm pressing the on-off switch and nothing is happening as we expected. I purchased this electric screwdriver because if you've ever worked on a 950, you'll know that Yaesu owns stock in a screw factory. There is screws everywhere. Okay, a bazillion screws later, the bottom cover is off, and we're going to be focused on the board under the DSP here. So we're going to take these 4 screws out next and get down to the control board. A sort of a note to anyone working on these radios: when you take them apart, you can see all the ribbon cables that are in here, and these cables are great. I mean, they eliminate thousands of wires, and it's the amount of wires or connection that's contained in these things is incredible compared to like the old 1000s that used to have the big wire bundles. But you have to be careful with them. When I take the ribbon cables loose, I'll always use a pair of forceps, just so that I'm not putting any pressure on the cable itself, on the ribbon cable itself, or especially doing anything like kinking this area right here. I have seen a lot of ribbon cables that are fractured because they're kinked right here. And you can see from the factory, which this radio looks very pristine, looks like it's never been into. You can see everything's nice and smooth. There's no kinks anywhere. So real important not to kink those ribbon cables. The thing I do is, rather than disconnect the DSP module, that's that big silver box there, I just kind of flip it up and out of the way and then use one of its mounting screws to temporarily move it up and out of the way, because we're going to be working on this board right here to start with. So let me get to the next step. Okay, I have 13 volts applied to this control board. And one of the things I noticed right off the bat is there is no red glow coming out of that LED right there. You can see it right at the top. I'll put it up at midnight here, 12 o'clock position. That's a little red LED. That would be lit if there were 13 volts making it to this control board. So there's no voltage, even though I've got voltage applied to the radio, there's nothing getting to the control board. We'll verify that here in a second with a voltmeter. Okay, voltmeter. And the place we're going to probe here is this is the 13 volt input side of the 3 volt regulator. This is generally what gets taken out when the power surge occurs. This is the main 3 volts, unswitched 3 volts that powers up pretty much the entire board, getting it ready for the on-off switch. And as you can see, there is nothing, nada. So next thing we're going to do is we're going to check the board for shorts. Okay, we now have the control board out of the radio and up here on my workspace. So we're going to do a little bit deeper diagnostic now. Next thing I've done is to remove the 3 volt regulator. And generally, in all the boards that I've worked on, and I can't even tell you how many, it's probably close to 100 of these things, I've never found a problem with anything other than 3 volts. The 3 volt always on circuit, and I'll elaborate on that a little bit later toward the end of the video, but I've never really seen anything other than the 3 volt parts being really bad, unless there's evidence of, I've even seen like in some of these 3 volt parts where there's nothing there but a crater. And I think I could put in a picture here or so in a minute where they're that bad and I've still gotten them working. So what we're going to do now is we're going to go back and check that same resistance that we measured a few minutes ago, where it was 5.1 volts. And we're going to go up here to the 3-volt line. I have seen the regulator shorted and causing an issue with it being really the only thing wrong. I have actually fixed some of these that, that's just because I'm moving, that the regulator shorted. But in this case, not. It's definitely the 3-volt parts. So what I do on all of these is I don't even, especially when they're zapped like this and have a short, I don't even check each individual 3-volt part. I just replace them. So I'm going to be replacing this IC, these two ICs, this IC, and there's a little tiny IC that's located right back here. Zoom out so we can focus. Right here. I'm going to remove those three and then we'll go back and check the resistance. Here's the bone pile of the 3-volt parts, and the only big 3-volt part that's still on here is that dude right there, and I got a funny feeling that we're still going to need to take that one off too. So let's see what we got here for resistance. Right there. We got an ohm back. Now we're at 6.5, where I think we were at 5.6 or 5.4, something like that. So yeah, we got a shorted processor. Sorry about the light glare here. Anyway, this is not a film studio. I don't have 9 oscilloscopes on the wall to impress you. I have one. It sits back there putting away. Actually, I have 2. I hardly ever use that guy, but old faithful. And anyway, so here we go. Here we go. We'll try. I'm heating the area around the processor. Trying to keep the heat nice and distributed. And we're going to lift that dude off. If you don't have these kind of tools, don't even think about going here, because you'll wind up with a totally trash board trying to do any of this with just a soldering iron. It ain't going to happen. Okay, the processor has been removed, and so has the other 3-volt logic parts. Are always sitting on the always-on 3-volt line, unswitched, I believe it's called. So now we're going to try and see what we have in terms of resistance. Just took my ground lead here, and go over here to the output of the 3-volt regulator. And we go up to the voltmeter, and what do we got? We got capacitors charging and discharging. Virtually no resistance on here at all. So you see the short is gone, and there's the bone pile. One of the things that's really important, I don't want to skip over this, is the prep for the pads for your new parts. It's very, very important to get those as with as much solder removed, I guess I should say, with as much solder removed as possible. You want those surfaces to be super flat and ready for solder and cleaned and all ready to go. That way the parts don't sit up on, if there's any residual solder, the parts leads will sit up on top of those mounds of solder, and you won't get good flow. Okay, we got the new processor installed, and now let's go ahead and install the rest of the interface ICs. Okay, the ICs are all installed now. Those two, that one up there, and the one buried right there. So all the ICs are in. I also jumped ahead here, and I installed the board in my test radio. This is when I do the boards where a customer just sends me the board. This is the test radio that I have here that I install the board in. And the reason why I do that is I want to baseline the fact that the board is 100% working. You'll notice that I don't have any of the ribbon cables hooked up at this point. What I'm going to do, reason why I've got it mounted here, is I'm actually going to do the programming, and that'll tell me that basically the computer and control board and everything is working. We'll do the programming first, and then we'll attempt to start the radio with this board. So I've installed the serial cable, the programming switch is in the on position. The power cable is hooked up. Let's turn on 13 volts and we should have an LED. We do. That means the voltage is being applied to the board. We'll go up here to the programming. We will hit, we can find the mouse, there we go. We'll hit right. And if we're lucky, we'll see a thermometer bar pick up here in just a second. And we'll start to see it program. There it goes. So we're programming. And rather than run the long video here while it programs, I'm going to stop at this point and we'll start back up after we're programmed. Okay, the programming is just about complete. Thermometer bar will get to the end there. There we go. We got the OK. That means the new processor is all flashed and running. So we'll hit that. And we'll close this. And we'll close this. And be back in a second. We've got all of the ribbon cables hooked up here. And we're ready to go. We're going to disconnect the serial cable. These programming cables are very finicky at times. And the other thing, can't forget this. We need to change the programming to the off position. So that must be in the off position, otherwise nothing will happen. Okay, so this is the board we just refurbished in our test radio. See what happens. Up we go. Okay, that board is working. Okay, and I'll show you now why we did it in our test radio first. Let me power this down. Okay, so we have the board installed in the customer's radio now. All the ribbon cables are hooked up, with the exception of the DSP. I'm not going to worry about that at this moment because it's going to just be out of the way. We're going to hook up the power cord there. That's all hooked up. And I'm going to double check the resistance here on the regulator. Sorry about that. Okay, so I go over here. You may recall what it was. Ohms would be nice. There we go. Ohm meter. So we're looking good here. Very high resistance, which is in capacitors charging and all that kind of good stuff. So that's all a good sign. But my money is based on how much or how low resistance this was, that when I turn on the power, that red LED is not going to come on. And it doesn't. That's why we baseline in the known working radio. So what's wrong is there is no 12 volts coming to this regulator. It's still dead. And I'll show you in a minute why. So we're going up top. We got the top cover, radio cover off. Now we gotta get out the electric screwdriver again because, as you can see, another plethora of screws. So here's the other half of the story. When the control board is that zapped, there's a high probability that the circuitry right here is bad. And I don't know if I can zoom in on this or not. I'll try. There are two little diodes right there. There's also a turn-on circuit. And what I found is most of the time that turn-on circuit on a board that's this shorted, control board that's this shorted, that turn-on circuit is also damaged. So those two diodes basically act as a fuse. So when the control board's pulling on a current, those two little diodes die. And usually about the same time it zaps that turn-on circuit. So we're going to go ahead and take this board out and basically rebuild this section of the power amplifier board. The PA board is now out of the radio. And as I mentioned, we're going to focus on rebuilding this area right here. Now, in order to rebuild this, getting into these diodes and so forth, the capacitor looks good, it's not swollen. So that's a good sign. Getting into these diodes, and also this little, what I refer to as the turn-on circuit. Let me see if I can get a good shot of this. It's really hard to see. You'll see more in just a second, but I'll explain to you. You can see that there's a transistor here, right center screen, a diode, and another transistor, and they're in the well between this big power relay and the power plug. So what we're going to do is we're going to remove that relay because we can't get into any of that. As a matter of fact, here, let's see here. I can't zoom anymore. I was looking to see if those sometimes those diodes are shattered. They look okay, but they're not passing voltage. Otherwise, we would see the red LED on the control board. So, be back to you after I get the relay out of the way. Okay, now that we got the relay out of the way, there's the two diodes that are blown. No question about that. And while I'm here, because I got the relay out and this has been zapped, I'm going to replace these three parts right here. Get my pointer. These three parts. That transistor, which turns on the relay. That diode, which is a transient absorber from the coil for the relay. And this is a transistor that changes from a 3-volt signal coming from the processor to the drive for that transistor right there. So we're going to replace all 5 of these parts. Okay, for this particular video, I went ahead and took the connector off too, because this is kind of an instruction for somebody who's getting just the control board service and want to do this work yourself. So the parts. Okay, here's the 3 parts that I replaced. This is the relay switching transistor. This is the diode for the spikes coming out of the coil of the relay. This shifts the level from the drive from the microprocessor, because that actually comes up here directly to drive that transistor. And these are the 2 power input diodes that are nice little fuses. So this gives you a kind of a good picture. Zoom in as best I can here and keep light on it, of rebuilding the PA board. One of the things I do before I put the PA board back in is I refresh the grease, the thermal grease. So we got good thermal conductivity. Okay, so we got the PA board all rebuilt. I just got it. This regulator here gets very hot very quick, so the only thing I've got anchored down right now is just that one screw, keeping it cool. But none of the other screws are in, just in case I got to take this back out. So anyway, first thing we're going to do is we're going to check and see if our red LED's coming on. Okay, we now have the DSP out of the way, and power is off. Let's turn the power supply on. See that we have a red LED. So that means that this board is getting power from the customer's radio. Okay, we got everything underneath permanently installed. And we're going to get ready for the moment of truth here. Okay, so power on. The moment of truth. Button pushing. Boom. There we go. Just like on our radio. Frequency. Looks like the customer was operating CW when this guy had its issues. So, and looked like we were on 40 meters. Yep, 40 meters CW. Alrighty. We're going to give this old girl a bath and send her back to a happy customer.